The universe isn't just vast, it's layered, interconnected in ways that bend the fabric of reality itself. Imagine worlds folded upon each other, sharing invisible points where different realms touch without us ever noticing. Today, we're diving into the mind-bending concept of the folded universe, exploring how multiverses could exist side by side, intersecting at hidden junctions that challenge everything we think we know about space, time, and existence. If you're fascinated by the idea that we might share our reality with countless other worlds just out of sight, you're about to see a whole new perspective on the universe's most mysterious architecture. The concept of the multiverse, foundations, and theoretical origins. The idea of a multiverse stems from the fundamental principles of quantum mechanics and cosmology, challenging our conventional understanding of a single, solitary universe. Quantum theory suggests that particles do not have fixed positions or states until observed, leading to interpretations like the many-worlds hypothesis, where every possible outcome of a quantum event branches into its own separate universe. This concept extends robustly into cosmological models, where inflationary theories propose that different regions of space could stop inflating at different times, creating a vast landscape of bubble universes, each with distinct physical laws and constants. These theories are rooted in mathematical frameworks, not direct observation, but they build a compelling foundation that hints at an infinitely layered cosmos. Mathematically, the multiverse is often explored through complex equations involving higher-dimensional spaces and string theory. String theory itself hypothesizes that fundamental particles are tiny vibrating strings existing in more than the familiar 4 dimensions. In some models, these extra dimensions fold and unfold in intricate patterns, giving rise to different universe configurations when viewed through the lens of the multiverse hypothesis. The concept of brane cosmology elaborates on this by imagining our universe as a membrane, or brane, floating within a higher dimensional space, with other branes possibly coexisting close enough to interact or influence each other. While these ideas are highly abstract, their roots are in attempts to unify gravity with quantum mechanics, a primary goal of modern theoretical physics. Historically, the roots of multiverse ideas can be traced to early philosophical debates about the nature of existence and infinity. However, the scientific foundations gathered momentum with the development of Einstein's theories of relativity and the realization that space itself could be dynamic and expanding. The concept was further bolstered by the discovery of cosmic microwave background radiation, suggesting a universe that began with a hot, dense state and evolved over time, leading some to speculate whether our universe is just one in a vast, possibly infinite, sea of similar entities. The notion that these universes could be interconnected in some way, touching at invisible points or folded within higher dimensions, stems from these modern theories, which seek to bridge gaps between observable reality and the mathematics underlying the fabric of spacetime. Though speculative, the multiverse's theoretical origins weave together quantum mechanics, cosmology, string theory, and philosophical inquiry into a tapestry that challenges our perceptions. It prompts questions about the nature of reality, whether different universes can influence each other through subtle connections or invisible points, and pushes the boundaries of scientific investigation into the very fabric of existence. The entire endeavor remains on the periphery of empirical science, yet these ideas continue to inspire new ways of thinking about the universe and our place within an enormously complex and layered cosmos. Intersecting universes, invisible touchpoints, and their significance. In the intricate tapestry of the multiverse, the concept of universes intersecting at unseen points presents a fascinating paradox. These invisible touchpoints, often conceptualized as thin membranes or branes, serve as silent gateways where separate realities momentarily align or overlap without colliding outright. The significance of these points lies in their potential to allow information, energy, or even matter to transfer between otherwise isolated universes, an idea that pushes the boundaries of traditional physics. Unlike physical borders we see and feel on Earth, these are not detectable by standard means. They hover in the realm of quantum and string theories, existing as delicate confluences beyond the reach of normal perception. Particularly intriguing are the effects these touchpoints could have if they were accessible or their connection to phenomena in our universe. For example, some theories propose that certain cosmic coincidences, such as the unexplained patterns of cosmic microwave background radiation, might be linked to contact points with neighboring universes. These intersections could temporarily alter the fabric of spacetime or produce fluctuations resembling quantum entanglement across dimensions. The potential for experimental detection remains subtle but compelling. Scientists explore ideas like the collision of brains, which might leave faint signatures detectable through gravitational waves or anomalies in high-energy particle accelerators, suggesting that these invisible connections could leave subtle footprints in our observable universe. Another vital aspect revolves around the stability and dynamics of these touchpoints. Not all intersection points are equal. Some might be fleeting, lasting only a moment in cosmic time, while others could be more enduring, perhaps acting as channels for cross-universal interactions. This variability influences how scientists interpret the potential for multiversal influence, whether in terms of raw physical exchange or the ripple effects that could alter the destiny of entire cosmologies. Theoretically, if an intersection point drifts or shifts due to cosmic expansion, it might influence phenomena such as dark matter or dark energy, acting as a hidden catalyst embedded within the universe's scaffold. The importance of understanding these invisible touchpoints lies not only in grasping the multiverse's structure, but also in unearthing potential clues about the origin and fate of our own universe. In essence, the study of these contact points emphasizes the interconnectedness of vastly different realms of existence, even if their connection remains concealed behind layers of dimensional complexity. Their existence hints at a universe far more interconnected than our limited senses can perceive, a cosmic dance played out on scales both infinitesimal and colossal. Unraveling their mysteries could redefine our understanding of physics, causality, and reality itself, suggesting that the universe we observe might just be one of countless overlapping layers in a multidimensional fabric that binds all existence together, yet remains invisible in plain sight. Dynamics of the folded structure, how universes converge and diverge. The concept of universes forming a folded structure suggests a complex, multi-layered fabric where different realities are intricately interconnected through invisible points. Unlike a simple multiverse where separate universes drift apart like isolated bubbles, a folded universe indicates compression and expansion within a shared spatial-temporal framework. In this model, universes don't just exist side by side, but are woven together with folds, regions where the fabric of multiple realities overlaps or converges temporarily. These points, often beyond current human perception, are where phenomena such as quantum entanglement or wormholes could be manifestations of the underlying structure of the folded universe. At these convergence points, the dynamics resemble a sort of cosmic dance of merging and separation. When two universes fold inward toward each other, gravitational or quantum forces might temporarily cause them to touch at single points. These are akin to invisible junctions that connect different realities without physical contact in the traditional sense. In theories related to string theory and M-theory, such points could be understood as branes or membranes intersecting at specific angles, creating a nexus where exchange of information or energy becomes possible. During these interactions, the universes may diverge again as the folds unwind, pulling apart along different trajectories influenced by the intrinsic curvature of the multidimensional space. The process by which universes converge often involves a delicate balance of forces. Quantum fluctuations can push or pull the fabric into new configurations, effectively bringing two distinct realities into fleeting contact. Conversely, divergence often occurs rapidly, as the force fields revert the universes back to their independent states. These folding behaviors can be visualized as ripples or waves moving through the fabric, a kind of breathing of the multiversal structure. The size and duration of these contact points depend heavily on the underlying dimensions and the energy dynamics involved. Higher energy states might produce more frequent or prolonged intersections, possibly affecting the physical laws within those points and even allowing for brief exchanges of particles or information. Interest in the dynamics of a folded universe extends beyond theoretical musings. Some scientists propose that these invisible convergences could be responsible for anomalous phenomena observed in quantum physics, like entanglement, or provide pathways for hypothetical forms of faster-than-light communication. The divergence itself might be visible in cosmic signals or subtle anomalies in the fabric of spacetime, hinting at interactions occurring at a scale far beneath our current detection capabilities. It's a universe constantly sculpted by the tension between these foldings, the momentary closeness of realities, shaping a cosmos that is far more interconnected than we might normally perceive. Implications for reality: what the folded universe means for our understanding of existence. The idea of a folded universe challenges the foundational notions of linear space and common perception of reality. Instead of a universe bound by straightforward dimensions, the folded universe suggests layers or membranes where multiple realities coexist in overlapping or interconnected ways. This concept draws from advanced theories in physics, such as string theory and multiverse hypotheses, where dimensions beyond our perception could host alternate versions of reality touching at invisible junctions. These touchpoints, or doorways, might be imperceptible to us but could allow for phenomena like quantum entanglement or even hypothetical travel between different universes. From a philosophical standpoint, the implications are profound. If multiple universes are compactly folded together, it implies that our universe is just one surface or sheet within a vast, multidimensional fabric. Events in neighboring realities could influence ours in subtle or dramatic ways through these unseen intersections, blurring the boundaries between what is real and what might be a shadow or ripple from another universe. This concept nudges us to reconsider the nature of existence, suggesting a web of interconnected realities where causality might not be as fixed as traditionally believed. This interconnectedness hints at a universe far more dynamic and less isolated than Einstein's spacetime fabric. Practically, understanding folded universes opens a trove of possibilities and paradoxes. For example, if certain points in different realities are touching at invisible nodes, then harnessing these junctions could theoretically lead to new modes of communication or transportation, albeit far beyond our current technological reach. It also raises questions about the nature of consciousness, whether awareness itself could be a bridge across these folds. Could perceptions or memories sometimes be echoes of other realities bleeding through these hidden intersections? Theoretical physics is exploring how quantum mechanics might offer a glimpse of these connections, with experiments hinting that particles can influence each other instantaneously over great distances, perhaps by hopping through these unseen folds. Ultimately, the notion of a folded universe complicates our understanding of what it means to exist. It paints a picture of reality as an intricate tapestry woven with countless layers, some accessible and others forever hidden behind these invisible junctions. It suggests that what we see, feel, and measure is only a fragment of a much larger, more complex structure. This perspective redefines reality as an ever-shifting landscape, where the fabric of existence could twist and fold in ways that remain beyond human perception but are woven into the very fabric of the cosmos. It invites endless questions about the limits of knowledge, the nature of consciousness, and whether our universe is just one of many interconnected tapestries in a grand, multidimensional symphony. Usnovnoy, Razgil 5. In the concept of the folded universe, the idea of multiple universes intersecting at unseen points introduces a fascinating layer of complexity. Picture space-time itself as a multidimensional fabric, woven with countless layers that, under certain conditions, touch at points invisible to conventional observation. These contact points, often termed as folds or wrinkles in the fabric, allow for the theoretical exchange or proximity of different universe realities without their intersection being overtly perceptible. This is not merely a poetic idea. Some theoretical physics models, especially those rooted in string theory and higher dimensional spaces, explore these possibilities as legitimate phenomena. Within this framework, the main domain 5 could explore how these hidden contact points influence the multiverse's structure. For example, These invisible intersections might serve as portals or gateways that are stable enough for particles or information to transfer, without collapsing the separate identities of the universes involved. Such interactions could mean that phenomena observed in one universe subtly hint at influences from another, even if no direct connection is apparent. This ties into how some cosmological models suggest that our universe might be one of many, and that these interuniversal connections could account for certain anomalies in physical laws or unexplained cosmic events. Specific models propose that at these folded points, certain physical constants or states of matter could temporarily align, allowing for unusual events, like the spontaneous appearance of particles or fluctuations in dark energy. These effects are hypothesized to be rare and highly localized, existing only at the smallest scales and in the most extreme conditions, such as near black holes or during cosmic inflation. For instance, some scientists theorize that quantum tunneling might occur across these invisible boundaries, enabling the transfer of information that manifests in observable phenomena like cosmic ray bursts or deviations in expected particle interactions. The implications are vast. They suggest a universe far more interconnected and layered than our straightforward perception could ever convey. On a philosophical level, the notion of intersecting is compelling because it implies an underpinning unity beneath the apparent diversity of realities. Despite being separated by immense dimensions and separated physically, these universes might be woven together in ways we are just beginning to grasp mathematically and conceptually. Some theorists entertain the possibility that understanding these hidden contact points could eventually lead to a unified theory of everything, bridging quantum mechanics and gravity through the language of multidimensional folds. These ideas challenge notions of separateness and suggest a broader, more fluid cosmos where the boundaries between realities are more like ripples on the surface rather than walls separating distinct worlds. As we've explored, the folded universe reveals a fascinating tapestry of interconnected realities, where worlds brush against each other at invisible points, creating a cosmic dance that blurs the boundaries we once believed defined them. These concepts challenge our understanding of existence, inviting us to see the universe as a complex, layered fabric of possibility. If that sparked your curiosity, you're not alone. There's so much more to uncover about the mysteries of the multiverse and the unseen connections shaping our reality. Stay tuned for future videos where we'll dive deeper into the science, theories, and possibilities that keep pushing the edges of our understanding. Thanks for joining me on this mind-bending journey. Your interest keeps these explorations alive. Don't forget to like, subscribe, and hit that notification bell so you don't miss what's coming next. The universe is vast, and there's always more to discover just beyond the horizon.